All right. I'm going to review this class, and we're going to talk about the final exam, and the rest of this week is for you to prepare to study for the final exam. We are going to have the final exam on December 6th from 10 o'clock to 12 o'clock. So please be on time and just 5 minutes before 10 o'clock and to get situated and get ready and for the final exam. All right, so let's look at the data structures class. We started with chapter 18 on recursion. So this is chapter 18 on recursion. Now this is very useful programming technique to solve the problems with inherent recursive nature. So for this kind of problem, using recursion, you can get a straightforward, simple, elegant solution without using recursion, and normally it's going to be a lot of effort. And using recursion and also will not make your program less efficient. And this for this kind of problem with inherent recursive nature. So we're going to apply recursion. So you see it throughout this class and with data structures, and particularly the recursive data structures like the trees, and we apply recursion to get the elegant solution. So this is the recursive programming technique. So in programming, in general, we have the paradigm. It's called imperative. Imperative is the one you started and when you learn programming in 1301. So you have the loops, and using all this the loops, and so this is the iteration, and so this is the imperative paradigm. And the object-oriented paradigm is, so we know we write the code and look at your application in terms of the objects, and objects interactive together, and you define the objects and using classes. So this is object-oriented approach. So this is third paradigm is this using recursion. And there's another paradigm, and in the future you may get into, it's called a functional paradigm. It's a functional programming language paradigm. It is actually already in the Java language. We already use it. It's using lambda expression, and that is considered as functional programming. So this is four paradigms. There are some languages. It's very specifically, it's a functional programming language. It's completely things. Everything you write is functions, a functional programming language. So Java is kind of mixed, has all things, and you have this the imperative. So you're using the loops, iterations, and you have the object-oriented, and you have recursion, and also with the lambda expression, and that's kind of functional programming. So it's all, you can see this is how it works in this language. All right, and so this is what we started with, recursion in chapter 18. And then we get into generics. So this is the for the syntax of the Java data structures, and we have this generics is all this the element type in the data structure, and they have the generic type. So this is generics. So this mostly it's about syntax in Java language regarding generics. And then we get into the Java API support for lists, array lists, linked lists, for stacks, queues, and priority queues. So how we use the data structures. So these are the common data structures you're gonna also in other programming languages and supporting the lists, stacks, queues, and priority queues. And there's another data structure here is the sets and maps in chapter 21. So these data structures are very efficient. So if you don't care about any certain sequence and accessing elements using index, so you can use the sets, and the elements in the sets are not in any particular order. So this is a hash set. So there's variations of sets in Java. It also supports linked hash set and supports the tree set. The maps is very similar to sets. In sets, you have just all the elements. You can consider all the elements are the keys. And for the map, the elements are entries. And each entry has this key value pairs. So this is maps is also known as dictionary. In the Python language, it's actually called dictionary. So it's the same thing. You have the key and value. So you use the key to search for the value. So this is the key value. That's why it's also called a map. The map together. So this is the map. And so the next, we started measuring efficiency of your algorithm. So this is we introduced the big O notation, the theoretical big O notation to measure the time complexity of your algorithm or your program. So a program is based on the algorithm. Algorithm is essential description of the program. So this is the using the theoretical notation, the big O notation. So the big O notation, it's independent from the hardware and independent from any specific input. So this it's a very good measurement. It's theoretical measurement. It actually very well predicts the performance of your algorithm. So theoretical notation, big O. So the big O notation is to measure the growth of the time complexity as the input size grows. So the input size doubles, triples, and 10 times. So what happens to the time, the execution time? So that's the prediction. It's a big O notation that measures this, the growth rate. So the techniques you're gonna learn in the future, you have another class, it's the algorithm analysis. You can learn the techniques for developing algorithms. So I think you need to know, we have some of the examples in this, throughout this, the class. So we have the examples of the divide and conquer approach. We have the dynamic programming approach, and we have the greedy algorithm. So those are the things you're going to know more in the future the algorithm analysis class, but this is something you just have to have the knowledge, good knowledge, and you're going to apply it in your future development to develop the algorithms. All right, so the next chapter we look at is sorting. Sorting, how do you sort? Sorting is a common programming task. It's very important, so it's very well studied. So we introduced a variety of sorting algorithms in this chapter. So introduced insertion sort, bubble sort, merge sort, quick sort, and heap sort, and radix sort. So all of this, and they're very important. It's classic. You need to know, what is radix sort? You need to be able to describe it. And so what is quick sort? You need to be able to describe it, and heap sort, how it works. And these are really fundamental. It has multiple purposes. So it's the first thing is they're very useful. And the second thing is, and through all this, and give you the examples and for developing your own algorithms. So next chapter, we look at how we're going to implement this data structures and list, stacks, queues, and priority queues. And through the implementation, and you gain deep understanding of the data structures, and you know why, and this data structures is good for this kind of application. So this is the variety of data structures, and we're going to use and to process data. So which one to use, it really depends on application. So like array list, linked list. So we use array list for most of the applications, but we use linked list for things like we do frequent insert and delete at the beginning of the list, and because that's super efficient. It's all of one time. It's the constant time. So we look at the implementation of stack. Stack is implemented using the array list. Queues is implemented using linked list. And priority queue is implemented using a heap. And then we get into this binary search tree. And this data structure, we define the binary search tree class and to model the data structure. So the binary search tree is you have this is the binary tree, and it's a search tree as a search property is for any node in the tree. The left subtree is less than this node, and the right subtree is greater than this node. So because of this, when you perform a search, you start from the root, you compare the element with the root. If it's less, you go to the left. If it's greater, you go to the right. So that's a search property. All right, so the binary search tree is this studied in chapter 25. In chapter 26, we studied this aviary tree. It's a variation of the binary search tree. In this aviary tree, it's guaranteed that the height is in order of n. This is the magnitude. It's order of n, it's the height. Order of log n, it's the height. Order of log n, it's the height. So it's guaranteed the time complexity for insertion, deletion, and a search. In the aviary tree, it's order of log n time. And then in chapter 27, we studied the hashing. So why the sets and the maps are so efficient and super efficient? Because the implementation internally, and we use a hash table. And the hash table is a hash function, and map the key into the index in the hash table in order of one time. And last two chapters, it's on advanced data structures and graphs and wedge graphs. So see how you develop new data structures for complex problems like graph, and the data structure, it's a graph, it's a data structure. So you define the class to model the graphs, and the graph, unwedged graph, and the wedge graphs. In wedge graphs, and we studied the algorithms, the minimum spanning tree and shortest path. So these are the things you will further study in the algorithms class. And so here, and the focus we have is to look at how you design and develop your own data structures. So the overall look at the curriculum for this class. So the first thing here is, and we get used to data structures in the Java language. And the second part is we look at the implementation of the data structures. And the last part is to venture into developing your own custom data structures. And so this is and overall, it forms a very solid content for the data structures class. All right, so the let's look at the final exam. A final exam, 2 hours. It's the the content we're going to have. This is comprehensive. It's accumulative. It's everything we have covered in this class, and will be on the final exam. And there will be 2 programs, and I think it's probably like 25 or something around this neighborhood of the multiple choice questions. So you're going to see we have double time than the normal the exam you have. So, and so now you have 2 hours, and so we have more time to work on this the programs and the multiple choice questions. So it's just going to be same format as you did before, and so I will let you submit it to Folio. So you just submit 1 file and to Folio. All right, I think I'm going to show you one more thing here is the, let's look at the, so I'm going to go on to Folio. So let's look at the syllabus now. Where's this? Okay, so we're going to look at this grading here. All right, so this is very good, and so now you are here and you attend the class, and so the overall it gives you 5%, and this is the 5% attendance. Yeah. All right, and programming exercise is 40%. So that's all from the Rebel. It's including the quiz. So this is the quiz. This is the everything, and from the Rebel book, you have done all the quizzes and all the programming projects. So this is all the exercises, and we already have the 2 exams, and each is 15%, and the final exam is 25%. So once I have this final exam, and I will put all this into a spreadsheet and give you the final grade. Okay. Any questions?
Nope. No, sir.
So please email me if you have any questions. Okay. So remember, be 5 minutes and before the exam. The exam is on December 6th from 10 o'clock to 12. So here, if you look at this, the announcement here, and I have this, the final exam, and this is the, so December 6th, 10 o'clock, okay. It's comprehensive.
I do have a question regarding that exam.
Yes.
So I was just wondering, you say it's comprehensive. I just wanted to be sure. So if it's the same format as the prior exams, will it be open note in a similar way?
Yes. Yes.
Okay.
It is. Okay.
Okay.
Yeah.
When did you say, Professor, I have a question.
Sure.
When did you say you're gonna add our the spreadsheet for our grades again?
Yeah. Right after the Wednesday's final exam, and we probably can finish it by Thursday night. So I think, yeah, Thursday night.
All right, sounds good. Thank you.
Yeah, I'm gonna try to get it. Yeah. Okay, by Thursday night. Okay. So please join Zoom at 9:55 a.m. So please. Okay.
We still have class on Wednesday, right?
No class on Wednesday. We have all finished. And so you use the rest of the time and to study and prepare for the final exam.
Okay, thank you.
Okay. Any other questions? All right. Thank you very much for attending this last class. Have a good day. Goodbye.
Thank you.
Thanks for a good semester, Professor.
Thanks.
Yeah, thank you, sir. I found this. I just wanted to say I found this semester very enjoyable. With the especially with the algorithms that we've gotten to cover. And I actually prefer your teaching approach. You may not hear it from a lot of people, but your teaching approach with the Revel. I mean, you did write the textbook, so that's amazing. But I find it very easy to just see the textbook and the assignments in the same place. It's like very easy to reference for me. Sometimes that's hard in other classes. So thank you.
Thank you very much, Luke. Thank you.
Same here. I have to admit, I'm not used to learning on Zoom, but the textbook with the homework really did help a lot as well. So
Great.
yeah,
Thanks.
I appreciate it.
Okay. Thanks.
Have a good one.
You too. Bye. All right, I'm gonna end the class now. Bye.